Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here's information about online seminars and study manuals for exams PFM, IFM, and LTIM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible to the extent allowed by law donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today for exam FM, Financial Mathematics. A one-year maturity treasury bond with a semi-annual coupon rate of 10%, so 5% coupon every 6 months, sells for $102.08.75, so 87.5 cents. A treasury bill with one-year maturity sells for $93.35, so $93.35. Derive the current 6-month short rate and the forward rate for the following 6-month period. Note that we actually have to find two rates. Okay. Based on the treasury bill price, the one-year spot rate is S1 such that 93.35 is equal to 100 divided by 1 plus S1. And from that, S1 is approximately 7.12378%. You just divide 100 by 93.35, that gives you 1 plus S1, and then subtract 1 from both sides and get S1 from that. If we write S.5 for the 6-month spot rate and F.5, comma 0.5 for the forward rate from time 0.5 years to time 1.0 years, then the price of the one-year bond gives us these equations. That 102.875 is equal to 5 over 1.s.5 to the power 0.5. That's the present value of the coupon paid in half a year, discounted at S.5 spot rate for half a year, but this is an annual rate. That's why the whole expression is taken to the 0.5 power. So it's a rate for spot rate for 0.5 years, but annualized. And then 105 divided by s plus s 1 plus s 0.5 to the power 0.5 times 1 plus f 0.5 comma 0.5 to the power 0.5. That's the forward rate from time 0.5 to 1. That has to be equal to also 5 divided by 1 plus s.5 to the power 0.5 plus 105 divided by 1 plus s1, and we know s1. And 105 divided by 1 plus s1 has to be equal to 1.05 times 100 over 1 plus s1, because 105 is equal to 1.05 times 100. And 100 over 1 plus s1 is equal to 93.35, so this has to be equal to 1.05 times 93.35, so 98.0175. Therefore, 5 over 1 plus s.5 to the power 0.5 has to be equal to 102.875 minus 98.0175, and that's 4.8575. And now we can solve this for s.5, and s.5 will be equal to 5 over 4.8575 squared minus 1, and that's approximately 5.9533%. Furthermore, 105 divided by 1 plus s.5 to the power 0.5 times 1 plus f.5 0.5 to the power 0.5, that has to be equal to 102.875 minus 4.8575, from the very first equation we set up for the 1-year bond, and that turns out to be 98.0175. And we proceed to get, given that we found S.5, we can plug that value in and get that 21 over 1 plus f.5.5 to the power 0.5 is equal to 98.0175 divided by 4.8575. And we solve this for f.5.5, and that's turns out to be 21 times 4.8575 over 98.0175 squared minus 1. That's approximately 8.307109.4%, which is answer C. Please remember, this is copyrighted material. The problem itself comes from the Casualty Actuarial Society. The solution is mine. Good luck in your studies and good luck on the test.